Hi everybody. So I'm going to be demonstrating each one of the reactions on page 18 of your yellow packet. Okay, so the first one is CaCl2 solid, okay, which is in this bottle. It says CaCl2 on it. And then you're going to add water to make it an aqueous solution, okay? So you've got water. So I'm going to do it, but I want you to stop right now and make your prediction. What the procedure says is put a tiny scoop of CaCl2 into the test tube. So a tiny scoop. Doesn't really want to go down there. Here we go. Tiny scoop. Okay. Make sure you put the lid back on, right? And then it says add 1 full squirt of water. So what do you think? Is this going to be a physical change or a chemical change? Look at the reactions on your paper. Look at the chemical symbols. Okay. So what I'm doing is kind of swirling it, shaking it a little bit until it says swirl until you see a color change occur. Okay. So I see that I started out with a white solid and I added water to it, and now the solid has dissolved. So is that a physical change or a chemical change? Plus 2 NaOH makes CaOH2 solid plus NaCl aqueous. So I'm going to get the things. While I do that, I want you to make your predictions and write them in the chart. So your direction says put 1 squirt, it's a technical term for fill up the eyedropper and put it in the test tube, of CaCl2 into a test tube, and then 1 full squirt of NaOH. Okay, so you can see this is CaCl2, and then this one says NaOH. So I'm going to first add the CaCl2. Okay, notice clear, colorless. And then NaOH also starts out as clear and colorless. And swirl it around. Okay, so you can see these cool little white flecks that are just floating around in here. Okay, so that's the solid CaOH2. So from 2 clear, colorless liquids, I made a solid. Okay, so that would be a chemical change because something new has appeared. Alright, here's reaction 3. Look at your paper. It says CuSO4S, which stands for solid, plus 4NH4OH aqueous makes CuNH34SO4 aqueous plus 4H2O. So it's quite a complicated equation. So what do you think? Is this a physical change or a chemical change? Write your predictions down now where it says predictions. So the procedure for this one is to take a tiny scoop of CuSO4, tiny scoop, and add it to the test tube. Okay, so there it goes. See, I've got blue, a little blue solid in the test tube, and I'm adding a clear, colorless solution to it. So let's see what happens. Whoa! Turned a completely different color blue, like a dark blue, okay? So what do you think that means? Chemical change, Physical change. Was something new produced? All right, now we are on reaction number 4. It says CuSO4, which is a clear blue solution, and zinc, which is silvery metal, a solid, is going to make copper solid, and ZnSO4, AQ. So, write down your predictions. What do you think is going to happen? It says add a scoop of zinc. Again, we're using tiny scoops, okay? So I'm going to put some zinc in here. So you can see it's silver on the bottom. And then 1 full squirt of copper sulfate. Ready? Here we go. Okay. So immediately when I added that, I had some powder here that was silver colored. Okay. Now at the bottom, it has become a copper colored solid. And as I swirl it more, the solution becomes more clear. See that? The solution is a little bit more clear. It's less blue. And you can see more copper color at the bottom. Pretty cool, right? So equation number 5 says CuSO4, 5-hydrate. Okay, that's what I was using CuSO4, but in a solution form. This is CuSO4 solid. And it says it's going to become CuSO4 solid plus 5H2O. So the way I'm going to do this is I'm going to take my test tube. I'm going to add a little bit of the CuSO4 to it, a scoop, because it is, there you go. And then I'm going over to the Bunsen burner with my test tube clamp. This part, I'm heating it right here in the hottest part of the flame. As you can see, safety first. I've got my hair back and my goggles on. Okay, so I'm going to move the Bunsen burner down because the color changed. Okay, so this is right here, this is the color that I started with. Ooh, there we go. Blue. Okay, and this is the color I ended with. You look in there, it's like white. It's not blue anymore. So, is it a chemical change? It did change color. One aspect of chemical changes versus physical changes is that chemical changes cannot be reversed. You can't get it back to its original state. So I'm going to add more water and see if this goes back from this white color back to the blue color. Test tube is a little bit hot. That's why I'm using my test tube holder. Okay, so I'm just going to add a little bit of water here and see if it turns back to blue. So, I don't know if you heard it sizzle. A little steam is being produced right now because it was very hot. Okay, but it does turn back to that blue color. So this is a reversible reaction because CuSO4 5-hydrate means that there's water in this. When I was heating it up, I removed the water. But when I put the water back in, it goes back to the same blue color. Okay, I don't have the exact amount of water in, otherwise it would just stay a solid, but it's reversible. So this one is actually a physical change. Hi, okay, so I'm doing reaction number 6 now. This is a reaction between NaHCO3 solid and HC2H3O2, which is acetic acid, also known as baking soda, vinegar, okay? So the directions say to put a small amount of the baking soda in your large test tube, okay? So just a little bit with my spatula. It's a white powder. And then this is a clear colorless liquid, and it says to add 5 milliliters. So before I pour it in, make your predictions. Hey, so I am on reaction number 6. This is the one that says to take your acetic acid, okay? And take your acetic acid and measure the appropriate amount that's on the directions in your graduated cylinder. And so let's observe our first, what we're starting with, acetic acid, colorless clear liquid. And then we have NaHCO3, which is a white powder. White powder. Ooh. So I'm going to put a little bit into my test tube, and then I'm going to add, with the graduated cylinder, my acetic acid. Okay, so you can see lots of bubbles initially. When I touch it, it's getting colder. It's really cool, okay? This is why we need the big test tube for this one, because it makes a lot of bubbles. And that was 1 little scoop of the NaHCO3, and then 5 milliliters of the acetic acid. So you can see there's no more, here we go. There's no more solid left. It's just liquid, and there's a lot of bubbles. Okay, so bubbles are evidence of gas production, and our solid disappeared. So what kind of change do you think that is? Okay, here we go. I'm going to pour it in. So this is what happens when you add a little bit too much baking soda. Gotta clean that up. Okay, so now we are on reaction number 7. It says we've got aluminum solid and copper chloride, CuCl2, that's copper chloride, and it says it's going to make aluminum chloride, which is AlCl3, and copper solid. So make your predictions. What do you think is going to happen when I add this? Chemical change, physical change. What do you think you're going to see? It says it makes AlCl3aq and CuS. Okay, so now I'm going to add this clear blue solution to it, and we'll see what happens. So I'm just going to shake it because it takes a little bit of time. Okay, so you can see there's a lot of bubbling occurring. Okay, here we go. My test tube has steam. Okay, and the aluminum piece is now turning into a copper color. You can see it right there. Okay, this is the last reaction. It says cobalt 2 chloride solid to cobalt 2 chloride aqueous. So what I'm going to do is I'm going to put some of the cobalt chloride into this test tube, and I am going to heat it up. Why, do you ask? Because that's the procedure. Alright, so you can see this cobalt chloride is kind of a pinkish color. So I'm going to put a little scoop into my test tube, I dropped a piece, so I don't want to add that back to the bottle. That's not good. So first, I'm going to heat it up. So when I heat it up, what I'm actually doing is removing the water from it. So you can hear it, okay? You could hear the sizzling, and now it's done. So now it's like the pretty cobalt blue color that you might know, okay? A little bit more blue than my shirt. Just gonna make sure it's all heated through here. So what do you think is going to happen when I add water to it? Okay, so it's blue, and now I'm going to add water to it to make it aqueous. Ooh, that's too far. Alright, so what you can see is there's this really cool color change. It kind of goes from purplish to blue to a very dark blue. So why does that happen? If all I did was add water to it, or take water away from it, shouldn't it stay the same color? Why is it doing this when I heat it up? Okay, so now I'm removing the water again. You can see it's kind of really hot, so I'm not touching the test tube, but you can see it's a cool purple color. So it went from pink to blue to dark blue to purple. Why does it do that? What do you think would happen now if I cool this? I'm going to put it in some ice and we'll see. So now I'm cooling it off in a beaker of ice. So let's see what happens as I cool it, what happens to the color. So it was blue, now you can see it's purple. It's all purple now. So do you think I can get it, I just spilled some water. So do you think I can get it to go back to the pink color if it cools long enough? So what do you think is going on here? Okay, so the cobalt chloride, it says it's got some H2O in it. Alright, so first, what I did is I heated it up. And it turned a cool kind of blue color, right? And then I added water. And when I added water, you can see there was this huge change. It went from blue to purple. So it was getting really hot. This did not happen when we did this with the copper chloride. Alright, it's getting a lot cooler now, so now you can see as it cools, it goes back, starts getting back to the original color. So how does heat affect the color of the solution?